Newton's second law. Okay, what if we have an object? Okay. Now we will deal with the mass. From now on, we need to know what is the mass of that object. The mass is measured by a kilogram. We have a motion, our motion in just one dimension. And we have a force, which is an interaction between two objects. The actor of this force, maybe it is me. The object has a mass m. This, and we don't have any friction force, so this object will start moving. After 1 second, for example, it has a velocity, but the force is exist. Then the force will act on that object to increase its velocity. After 2 seconds, it will have more velocity. After 3 seconds, it will have more and more velocity because the forces exist. Assume yourself are pushing on the gas for the car. It will continue increasing its velocity, right? This is with a mass m. What if I need to put some numerical values just to make this experiment more sensible? If my force is 10, if my mass is 2, okay? What if my force now is 10? Okay. But the mass is 5. Do you think the mass will gain an acceleration and velocity the same as the first one? This is m1, this is m2. Do you think it is the same? Another word, if I need to push small thing, just like this razor, it is simple to push it. But what if I need to push the monitor? It is more difficult. I need more force to make it accelerate with the same rate. To make it shorter for you, and simply more simple. Newton's second law, the force is equal to the mass multiplied by the acceleration. The force is a vector quantity. The acceleration is a vector quantity. And the force has this property, which is the vector, from the acceleration because the mass is scalar, just a number. And the direction of the force is the same as the direction of the acceleration. And the acceleration is delta V over delta T, as you know. Okay? Now this is the force. If I have a force 10 newtons, the unit of the force is a newton. The mass is 2. How much the acceleration? Something multiplied by 2 will give me 10. It is 5 meters per square second. Okay. In the other experiment, the force is 10 again, but the mass is 5. What is the acceleration in this case? It's 2 meters per second square. As we see, if we have a force, and this force is constant, still, we increase the mass, then the acceleration will decrease. We don't have the same acceleration. This acceleration is constant. It's okay. Now, what if I need to change the force and make it 20 and keep the mass 2? Okay, the force is 20. Now, at first it's 10, then it will be 20. The mass is the same, 2. What is the acceleration now? Look, we just have this formula. Here, it is 5. Here, it is 10. If we increase the force, for example, I am pushing by 10. Then my friend start pushing with me by another 10. It will be 20. Then the object will start moving faster and faster. This means its acceleration will increase, will change. Okay. So the interaction between objects using Newton's second law depends on the force, the mass, the acceleration. We have 3 things from the law. This is a vector quantity. So we have fx and fy. Because of that, we need to know that we have also ax and ay. I can write it like this. I will remove this. Any question about Newton's second law? Are we allowed to use calculator? Yes, sure. You can use any calculator. I have this one. All the constants are carried here, and I can convert any quantity to any other quantity as I need. I'll not say its name, you know it. Okay, now you can use your calculator. Also, you can use, don't use the phone calculator. You don't have time to go to internet or to phone calculator. There on Lookdown browser, there is an application at the corner. You can use it for the calculator. The force. We have Fx I hat plus Fy j hat. I will not talk about z hat. Is equal to the mass multiplied by Ax I hat plus Ay j hat. Simply. So Fx is equal to m Ax. Also, Fy is equal to m of Ay. Right? Now these are scalars. This is the component, x and y, just the components. Okay. Yesterday we talked about the vector nature of the force, and we can find the magnitude of the force by finding the absolute value using the Pythagorean theorem and the direction of that force. What else? Any question about force? What is the vector mass?